So today we will learn the area of a polygon. So probably the first shape you have learned how to find the area of is a triangle. And there's two ways you may find the area of a triangle. One, anyone know the formula to find the area of a triangle? You remember? Do you remember? No? It's area equals 1/2 base times height. Base being the bottom, so in this example, this would be my base, the bottom. If you need to rotate a triangle to make a different looking base, you can. And then height, you measure bottom up, so you would measure from the top down, and this would be your H. So it's 1/2 base times height. Now I'm going to teach you a new way, and let's say you don't know the base, but you know, what do I want to call this? Like maybe this, you could call this side 1, and this side 2. And say you know this angle. If you know an angle of it, and then you know the side that is directly next to that angle, there's a formula, and the area is 1/2 times side 1 times side 2 times the sine of that angle. Does that make sense? So I'll make up an example down here. I don't want to cover too much, but area of a triangle, it's the same thing we just wrote, but here's how you find the area of the triangle. Okay. So an example real fast. Say you had this. And you know this is 4, and you know this is 5. And you know this is 6. And they tell you this angle is 30 degrees. Then you can find the area. And the formula is area equals 1/2. Does that connect to the 4, 5, or 6? Going to be 2 of them. It connects here and here, right? So you're going to use 5 and 6 in the formula because those are the sides on either side of that angle. So you're going to go 1/2 times 5 times 6 times the sine of that angle that's in the middle, 30 degrees. So 1/2 of 30 is 15. So it's really what's 15 times sine of 30. Make sure I'm in degrees, yep. And that's 7.5. Does that make sense? So to find the area of a triangle, if you know the side and the angle in between those two sides, you just plug in the formula 1/2 times side 1 times side 2 times sine of the angle in between the two sides. Questions on that? And we're going to learn today. Now, find the area of, I need to change this, of a triangle. We're going to go back and we're going to talk about all kinds of different shapes. Please do not make fun of my drawings. I'm not very good at drawing. So let's start. Let's start with, we'll make this be our shape. We'll let this column be the sum of the interior angles. We'll let this be the number of sides. We'll let this be each angle. And then we'll let this be the area column. So let's start with the very first one we usually talk about, and that's a triangle. So a triangle has how many sides? 3. Okay. We're also going to be talking about a rectangle. Because it's regular, the word regular, in case you don't remember from geometry, means all sides are equal. So this equals this equals this. So it's like 2, 2, 2, 3, 3, 3, 4, 4, 4. It's called an equilateral triangle. So if you have a 4-sided shape, where all sides, that's called a square. A 5-sided shape, anyone know what that's called? So I'm very bad at drawing. So usually you're like this, 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 this. It's not too bad. You call that a what? Huh? So this is triangle. This is called, instead of calling it a square, we could call it a square or quadrilateral. This is a, what'd you say? I heard someone say it. There's 5 sides, just like there's 5 branches of the military, and each branch is housed in the Pentagon. And then you have a 6-sided figure, which kind of looks like this. And I'm sorry, I'm very terrible about drawing. And imagine all those sides. I'm not a very good drawer because it's regular. This has 6 sides. Anyone know what you call a 6-sided hexagon? And you can look up the rest, okay? But a shape could have any polygon. Let's let number of sides be n. That way we can make a formula. I mean, you could keep going. 7-sided, 8-sided, 9-sided, 10-sided, 11-sided. Okay? Now help me out here. Do we know what the interiors add up to in a triangle? 180. Good. So the sum of the interior angles of a triangle is 180. In other words, all the angles inside the triangle add up to 180. What about a quadrilateral? Anybody know that? 360 degrees. Good. Pentagon? $540. Basically, every time you add a side, you add 180, right? So 360 plus is 540. You add another side, you add another 180. So what's 540 plus 180? 720 degrees. And then next, you would add 180, keep adding 180. Now there is a formula for that. You take the number of sides, subtract 2, do that first, and then multiply it by 180 degrees. That's the formula. So triangle, 3 sides, 3 minus 2 is 1, 1 times 180 is 180. Quadrilateral has 4 sides, so you go 4 minus 2 is 2, 2 times 180 is 360. Pentagon has 5 sides, so you do 5 minus 2 is 3, 3 times 180 is 540. Hexagon has 6 sides, so you do 6 minus 2 is 4, 4 times 180 is 720. That formula always works. Questions? So, if all the angles add up to 180, and there's 3 sides, and all sides are the same because it's regular, that means all angles are the same also. So if you have 180 degrees split between 3 sides, how much is each angle? 60. Does that make sense? Because if all 3 sides are equal, that means all 3 angles are equal. You have 180 degrees split between 3 angles. So here, like, you have 360 degrees to split between 4 angles. And you already know a square, 360 divided by 4 would be 90, right? If you have a pentagon, 540 degrees, and you split it between 5 sides, which means 5 angles. 540 divided by 5 is 108. You take 720 degrees and you split it among the 6 sides that are the same, meaning the 6 angles are the same. 720 divided by 6 is 120. Now the formula is you take this divided by this, right? 720 divided by 6, 545. So you're going to take n minus 2 times 180 divided by n. So 10-sided, a decagon, you would take 10 minus 2 is 8. 8 times 180 divided by 10. Whatever that is. Who cares at this point? Does that make sense? All right, here's where it gets kind of tricky, and that's with the area. And I don't teach this very often. Now, for a triangle, we know that this is going to be 60 degrees, right? And if it's regular, that means these are going to be the same. So this would be x, 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 whatever x may be. So I would just use the triangle formula where you go 1/2 x times sine of 60. Does that make sense? So area would be 1/2 times x squared times sine of 180. I'm sorry, not sinus. I don't know where I got 180, 60. Can you guys see that? It's really small. So if you know the sides, you just take those, multiply them, divide by 2, then multiply by the sine of 60. And the sine of 60 sense? Like, the triangle is not hard. Like, if I say regular triangle, actually do it down here. If I say you have a regular triangle, and I say the perimeter is 9, then you should be able to go, oh, if the perimeter is 9 and all sides are equal, then my triangle, what would each side be? Well, not 9, the perimeter is 9. Take this plus this plus this is 9, but all 3 sides are equal because it's regular. So it'd be what, 3? 3 plus 3 plus 3. And because all sides are equal and it's equilateral, this is 60. So you would just go area is 1/2 times 3 times 3 times sine of 60. Type it in a calculator. And you get around 3.90. Does that make sense for triangles? And we use this 3 and this 3 because they're on either side of that angle. But because they're all the same, it doesn't really matter. Does that make sense? Alright, next. I wish these boxes were a little bigger. Let's say we have a quadrilateral where it's regular, that means basically a square. Assume that's a square. Basically what we're going to do is every shape has a center. Say it's there. And we can make a triangle here. To make 90 degrees. And I'll show you why we're going to do this. But basically 4 of these triangles would fit in this shape. And there's other ways to find the area. I'm just going to show you the way that makes sense to me. So if this angle is 90 degrees, then this means this angle right here, I really need a smaller pen, but this angle would be 45 degrees. Does that make sense? Because it's half. Are we on the same page? So let's do an example with quadrilateral on the back. Let's say, I say it's a regular quadrilateral, perimeter equals 16. And what is the area? So regular quadrilateral, that just means a square. It looks like a rectangle, I'm sorry. Has a center. Make a triangle. Now, if the perimeter is 16, that means each side is 4. So essentially what I'm going to do is I'm going to take this triangle right here and recopy it just to work with. So imagine that is that. And how many of these triangles fit in here? Any idea? So if 4 fit on the bottom and 4 fit on top, so there's 8. Does that make sense? So if this is 45, well, I didn't tell you what this is, but 90 degrees, it cuts in half, so this is going to be 45 degrees. And if this was 4, and this cuts it in half, this means this is 2. It's half of that side. And the area of a triangle is 1/2 base times height. So I need to find this. Well, I know trig ratios, and I know that the tan of 45 equals TOA, x over 2. And then if I solve that, I get 2 times tan of 45 equals x. Type that in your calculator. And you get 2. So the area is 1/2 base times height what's the base of this triangle? 2. The height is also 2. So half of 2 times 2, 4. Area, half of 4 is 2, right? So the area of this little triangle here is 2. So you would go 2 plus 2 plus 2 plus 2 is 8, right? And then 8, so you're going to have more. You have a total of 8 of those. So if you add 2 8 times, you get area of this is 16. You guys know an easier way to do this in a rectangle? To find the area? Multiply what? Huh? Yeah, you could have just took 4 times 4. You got the same thing. Length times width. You're welcome. Isn't that kind of cool how the triangle worked in there though? And the reason why I showed you this, even though it's easier just to take 4 times 4, is this is the method we're going to use for any shape. We're going to draw a triangle, find the area of that triangle. Triangles that fit is always double the number of sides. So if this has 4 sides, there's going to be 8 triangles that fit in there. So if you find the area of one triangle, and by the way, this x is actually called an apoptome, but we're not going to go into that. You can find the area of any shape. Okay? Pentagon. Guess I get to draw one of these pentagons again, huh? 1, 2, 3. This is terrible. They're supposed to all be the same length. Maybe you do better than me, but that is definitely not a regular pentagon. All the sides are supposed to be the same. And I use pen. So the center would be about right here. We can make a right triangle. We can find the area of this triangle. If this is 108, cut it in half, this right here is going to be 54 degrees. And there's going to be 10 of those triangles that fit. So once I find the area of this triangle, and multiply it by 10. You want to see an example of a pentagon? Okay. So an example. I almost used way too much room for the... What if I say it is a regular pentagon perimeter equals 15? What is the area? So first thing I would do is I draw a pentagon that looks regular. And again, I don't know why, I just never learned this skill. That means all sides are equal. So if there's 5 sides, and all the sides add up to 15, 15 divided by 5 is what, 3? So 3, 3, 3, 3, 3. We're going to find the center point and make a triangle. We're going to find the area of that triangle and then multiply it by 10 because there's 10 of those that will fit in there. 2 for this side, 2 for each side. 2 triangles for each side. So this triangle, if I replicate it, I'm going to make it bigger so it's easier to work with. We learned that then each, I don't remember off the top of my head, but each angle is 108, right? That's what we learned in a pentagon. So if you're dividing it in half, that would only be 54. So this angle right here is 54 degrees. Because the triangle is not the full length, it's half of it, this is 1/2. So we need to find the height. And it's always going to be tan, by the way. So you say, okay, tan of 54. So SOHCAHTOA, O and A, equals H over 1.5. Multiply both sides by 1.5.